When you first start Leadwerks 5 for the first time, the first thing you'll see is the project manager. Before we do anything else, we need to create a new project. So we just press the create button here. And we can set the name of our new project. We can change its location if we wish to. You can choose the language, and we have a few templates to choose from, but I'm just going to leave it as a blank project. And just press the next button when you're ready to create the project. And this will just copy all the files necessary to run the project. And now it's been created, and if we just click on it, then it will open this project up in the editor. Primitives are simple geometric shapes that you can use to build your game levels. To create a primitive, we need to select the Object Creation button here, and if we click on the left arrow here, we can see the different objects we can choose from. We have 4 primitives to choose from. They are box, wedge, cylinder, and cone, and all of these can be modified so that you can turn these into pretty much any kind of architectural details that you want. So to create a box, we're going to left click with the mouse and just drag a box out. And we can resize this outline, and we can move it around if we need to. And once you have it in the place you want, you can either press the Enter key or you can right-click with the mouse and select this Create pop-up menu to create the object. Now some primitives, like the cylinder, are going to have an extra step. Let's create the shape we want. And then this dialog opens, and this allows us to adjust the number of sides that we want to create the cylinder with. The mouse tools allow you to select and edit objects. All the available mouse tools are listed right here in this sidebar, in this column. The first is the Selection tool. And you can use this to simply click on an object to select it. If you hold the Control key while clicking, then you can select multiple objects, or you can deselect one object at a time. If you hold down the left mouse button and drag the mouse, then you can create this selection bounds, and then that will just select any objects within it. And this works in the 2D or the 3D viewports, of course. The Translation tool allows you to move objects, either in the 2D viewports like this, or with this gizmo in the 3D viewport. And if you hold the Shift key while you're dragging an object, then you'll make a copy of the object. So that's just a really easy way to quickly make a lot of copies of something. The Rotation tool allows you to rotate objects, again, either in 2D or in 3D. And if you only have one object selected, then the rotation will be around the center of that object. But if you have multiple objects selected, then they will all be rotated around the center of the selection bounds. You can use the Scale tool to resize objects, either in 3D like this, by just selecting any face and dragging it, or in 2D by grabbing the edges. Boolean operations are really handy tools that allow you to modify primitives. We have two Boolean operations, carve and hollow. So I'll show you carve first. Let me just create an object. And now I'm going to create a second box and just make sure that it's intersecting the first one. And then I'll take the carving, I'll select the object that I want to use to carve, go to Tools, Carve, and remove it, and it made a hole in the wall, in the floor. This works with all shapes, not just boxes. So I can create a cylinder like that. Carve it. And voila. So that's just a really easy way to make doors and windows and other things. Now I'll show you the hollow tool. This is really simple. I'll just create a box and then go to, with the box selected, I'll go to Tools, Hollow, and it just uses the grid size of the active viewport for the hollow thickness, and we just turn that box into a room. Let's take the roof off. There we go. When an object is selected, its properties will be available under the Scene tab at the bottom here. You have these three groups: Transform, Appearance, and Physics, and all entities have these properties. The Transform properties include position, rotation, and scale, and you can use this to just adjust the position very finely. You usually don't have to use these. Usually the mouse tools are sufficient, but it's nice to have it when you need it. Under the Appearance properties, you have Color. You can use this to change the color of objects. And this brightness value, this is a multiplier that allows you to create colors that are brighter than what the color picker here supports. So you can use that to crank up the brightness out of the range of what this supports. I'm not going to talk about every property here. If you're curious to learn more, I would encourage you to read the article that goes along with this video. You've also got physics properties, mass, collision type, pick mode for raycasts, friction, and other properties. The nav obstacle checkbox, this just controls whether the object interacts with the navigation mesh system for navigation and pathfinding. And down here at the bottom you have this Add Component button, and if we click this, we can add any component we want, and that itself will open up more properties which we can adjust. And it's not important to memorize what each of these are right now. Just know that if you have an object, its properties are going to be available under the Scene tab. And one more thing I just want to show you. When you have two objects selected, or more than one, if they have the same values, then they will appear here. And if their values are different, then the control here will look somehow different depending on what type it is. So for example, if I disable shadows here, and then I have one object with shadows enabled and one without, you can see you have this gray checkbox, and it's labeled that those two values are different. And then if I just check that, then now it sets it to true for both of them. I also want to show you how some entity types have different properties. So if I create a point light, we'll see down here there's a new group for light properties. And if we create a spotlight, we'll have this additional property here for the cone angles. And some of these entity types will have different properties. The lights do, the particles, the probe, the navigation mesh has a lot of properties that go along with that, as well as the camera. And so the interface will just adjust depending on which objects and what type of objects are selected. This scene demonstrates several types of lighting, and this is available in the download system. If you just click on Environments, and then you can download the lighting sample here, and just press the Install button, and that will download and install it. You need to be logged into your Leadwerks.com account, which is available here. If you don't have that, then you can register a new account at leadwerks.com/community, and then you can just download all of this for free. So we'll start with the point light, and this is very simple. It just emits lights in all directions. It's good for something like a light bulb or a torch. You have the range value, and this controls how far out the light extends to. And you also have a fall-off mode. You have the linear mode, which is a softer fall-off, and then you have the inverse square fall-off, which is it will stay brighter longer, but it has a much sharper transition at the end. The near range is used for the shadow map rendering, so that should just be a small value, but not 0. And then the shadow map size, usually you can just keep the default size, but if you have a light that covers a very large area and you need a higher resolution shadow there, then you can increase that if you need to. The spotlight emits a cone of light in its forward direction. You can see here that the spotlight is angled, it's pointing down at 90 degrees. If we set that to 0 degrees, then the angle of the cone, the direction the cone is facing, changes. A spotlight also has these cone angle values. These are the outer cone angle and the inner cone angle. And so if I increase this, you can see the effect that has. That makes a wider cone. And then the inner cone angle is the angle at which the light starts to fade out. So let's set this to 44 degrees. So they're going to be really close together. And so that transition zone between like maximum brightness and shadow is only 1 degree. If I set it to 40, then that spreads it over 5 degrees, and that gives it a smoother look. Or I can make it very, very smooth like that. The box light also emits light in a direction forward. And these are good this is good if you have an indoor scene, but you just want some sunlight coming through a window in one spot. Then a box light is great for that because it's a very simple light, and you don't have to have a full directional light, which is quite a lot more expensive. You can just place a couple of box lights wherever you have windows, and that will simulate sunlight coming in. And again, this is, if we change the rotation here, then you can see the effect that has. In the editor, you can have one directional light, and this is controlled up here in the World Settings dialog. The sun color controls the color of the sun, along with this brightness slider. You can use that to make it very, very bright, or to just adjust it gradually. Azimuth is just the Y rotation, so you can use that to rotate the sun angle. Elevation is just how high the sun is, so you can have a low elevation for a sunset, or a very high elevation. That'll make it like it's high noon. The ambient light level is usually you don't need it, but you can use it if you want. This will just add some solid light to the scene. And then the IBL intensity slider, this will control how strongly the environment maps affect the scene. So you can have this global skybox specular reflection map and diffuse reflection map, and these are typically stored in the same folder like this. Let's take another look. You can find them in materials, environment, and there's always one in default, and then you'll find some other ones that you can download through the Downloads Manager. But the skybox will look like that. The specular map, it's just processed specially. And you can see it gets blurrier at each map. And then the diffuse reflection map is a very blurry reflection of it's a very blurry version of the skybox. And these are used in the PBR lighting equation to make metallic surfaces look like metal, and plastic surfaces look like plastic. This helmet here is a really good example of that, of PBR material. You can see how shiny it looks. Now, if you have an overhang or an enclosed space like this little building, then let me hide this probe. The interior of that is still going to be using the PBR reflections that are set for the whole scene, and it looks kind of unnatural. So what I did here is I added an environment probe. And this just calculates a set of cube maps for this volume. So this little room here has its own set of reflection maps. And these are applied inside any object that's on any objects that's inside here. Now the probes also have a fade parameter for each edge. So by default you can see this sharp border here in the boundary between the probe and the outside world. You can see this very sharp boundary, and that's good when it's along the walls because we actually want that, but on this edge here it doesn't really make sense. So one way we can deal with that very easily is to just fade in that value. $100 looks okay. And then it just gives us a little bit more of a gradual transition, and it's even less noticeable when you have materials applied to the walls here. Now you can see the effect this has, especially on this helmet 3D model. The side that's facing us is not being directly lit, and when we push it back here into this room, then it has a very dark indirect reflection, and when we pull it out, it's still not being directly lit by the sunlight, but you can see it gets a lot brighter. Just the indirect lighting gets a lot brighter for it. So this gives us really fine control to handle indirect lighting for indoor and outdoor areas combined in the same scene. And it's extremely performant, so it's just a really nice way of handling indirect lighting and making sure you have pretty good looking reflections everywhere you go without while still maintaining a fast frame rate. In this lesson we're going to create a simple scene and add the player to it, and then we'll run the game with the player in it. So the first thing I want to do is just zoom out pretty far, and I'm going to create a big block here that's too big. I want it to be 1024 by 1024 centimeters. And then I'm just going to lower it so that it's even with the ground plane here. And then I want to create 4 walls, and I want each of these walls to be 256 units tall. I'll just copy that. There we go. And I'll just copy the floor to make the ceiling, like that. And now we have a totally enclosed room. Now I'm going to add a light inside the room. So select the point light object. And I want to put this right in the center of the room. And you can see the light range is not far enough to fill the room. So let's go here and set this to 6. That looks good. And now I'm going to select the pivot object, and I want to put the pivot, right where the player's feet are going to be. So it's going to be down there in the floor. And then I'm going to press the Add Component button and select Player, FPS Player. So that's done. And then finally I want to go up to World Settings. And I'm just going to remove the specular and diffuse PBR reflection maps because they're not really necessary since this is just an indoor scene. And then I can just I can either press the run button here to run in release mode, or I can go up here to game, run. And I also need to type, I haven't saved this map yet, so I need to type a name for it. I'll call it player test. And that's it. Now we have a first-person controller, and I can walk around I can look around using the mouse and move using the WASD keys. The space key will jump. So that's just how you set up a very simple game with Leadwerks. 3D models are detailed objects that are made in an external modeling program like Blender, 3ds Max, Maya. There's a lot of others. The easiest way to get 3D models into your game is to just download them from our downloads system. We have a lot of them available for you. Let's choose this one. We just press the install button. And there it is. We can open this up in the model editor and look at it. And if we want to place this in our scene, we just drag like this. And there it is. You can also download 3D models from external websites. I have a zip file here from a website that contains a GLTF file. And I'm just going to extract all the files inside this zip file into my models folder. And there's the model. If I double click that, it opens it up in the model editor. And usually, so GLTF files, they support PNG and JPEG textures file format. And this is not optimal for real-time rendering. What we usually want to do is go up to Tools and then select Convert Textures to DDS. DDS files are compressed in memory, and so they load faster, and they also use about 25% as much memory as like a PNG file does. Okay, it says we converted 3 textures. And then because GLTF does not support DDS files as textures, we want to save as, and we're going to save this as the Leadwerks model file format, which does support a lot of other features that GLTF and other file formats do not. And the GLTF loaded pretty fast, but this definitely loads faster. And you can see right here it's using the optimized DDS files for the textures. So that's just a very common process that you'll want to do when using the software. You'll usually import files as GLTF and then convert the textures to DDS and save it as a Leadwerks model, and that will give you the optimal loading time and reduced memory usage. Now this model is not super high poly. It's using 1700 polygons, which is fine. But if we want to, we can add some LODs to it. And an LOD, that stands for level of detail, and it's a reduced detail version of the model that is shown when the model is further away. So if we go up to Tools, Reduce Mesh, then we can use this slider to just gradually reduce the detail. It does a really nice job. So we're down to about 1130 polygons, so I'll just press Add LOD. That'll be my next version. And then reduce it a little bit more. Add LOD. It looks like that's about as low as it will go. And now you can see, here's our reduced version details. This one, okay, so the first LOD, that's the original mesh. That's 1700 polygons. This one is 1100 polygons, and the lowest is 482 polygons. And if you select the node here, the root, then right here, this LOD distance value, this will control the distance at which these different versions are shown. So let's just set these to be really low values so that we can see very clearly. Even then, it's pretty hard to tell the difference because you can see the change right there, but it's very, very close. which is that's what we want. We don't want it to be very obvious when you change LODs. And then when you're done, you just save. And because this is a Leadwerks model file, it will save the LODs. Other model file formats do not support that feature. So you want to use Leadwerks model file formats for that. We can also add a collider to this model, and that way it will be interactive with 3D physics. Now, by default, objects don't have collision unless they have a collider. So let's select the root node here, and then right here under physics, let's set a box collider. And that just does what it says. And now it will be, for the purposes of collision, this will be treated as a box. And we'll save that again. And then all of our changes are saved in the file. Now I want to show you how colliders work. By default, 3D models are not interactive with physics. You have to add a physics collider, which is a simple collision shape for physics to be active. And this is a really good model to test with. I'm going to select the root here. And then under physics, I can set the collider to box, and that just creates a box that matches the dimensions of the object. Well, I mean, that's not a very good match for this object. A cylinder isn't either. A sphere is not really appropriate either. Capsule doesn't really work. Convex hull is a bit better. That's not bad. But we have another tool that we can use, this special tool up here that's called convex decomposition. And what this does is it makes a series of convex hulls out of the shape. So let's see what it does by default. Oh, that's pretty good. It doesn't have to be a perfect match, but as long as it's pretty close, then it'll look good in game. So I'm going to save this, and I'm going to save as a Leadwerks model file format. This is a GLB file format, which is GLTF in binary form. But we want a Leadwerks model because that is that file format actually supports the physics colliders. Other file formats do not. So when we open this back up, we can see the physics collider is already applied to it. It's stored in the model file format. So this model is ready to use in-game. Materials can be used to change the appearance of a surface. You can use this to make brick or concrete or dirt look like the material it's supposed to be made out of. You can create a material just by going up here to this plus button and then select the new material menu and enter a name. And that's going to create your new material. It's just plain by default. So let's apply it to this object here just by clicking and dragging onto it. And we can change the material's color. You have a lot of different options in here, and I would encourage you to read the written article that goes along with this tutorial to learn what they all do in detail. The most important thing is this list of textures. And let's get another material so that we can explore that. Our download system contains thousands of game-ready materials for you to choose from. You just need to log into your leadwerks.com account and you can download all of these for free. Just press the install button. And let's choose the 2K version. And there's the material. Let's take a look at the material in the material editor. And you can see here we have a diffuse texture. That's a color texture. Let's take a look at what that looks like. And then you have a normal map, and this defines the direction that each pixel points in. This is used for lighting. You have another texture that is ambient occlusion, metalness, and roughness packed into a single texture. So it doesn't really look like anything, but it just has a lot of data. And then a displacement map, it tells you how high, it tells the engine how high each pixel is, and this is used for tessellation and displacement. Now to enable tessellation and displacement, we need to check this box here. And then you can see the features on the surface are actually popping out of the surface. And we can adjust the scale of this, and we can adjust the offset. Usually you want the offset to be a negative value that's half the scale, and that way the midpoint of the displacement map will be right in the middle where the surface would be with displacement disabled. So let's save that, save our changes. Now you'll notice I don't see any displacement in the editor here yet, so I'm going to go up to Options, and then in Video Options I just want to make sure that it's enabled. Let's set it to Ultra. And then I need to add some, I need to subdivide this face a bit, a few times. And now you can see those features coming out of the surface. This is really great for brick, snow, rocks. It just adds so much detail. And the reason you want to add that subdivision, you usually want it to be about every meter is good. And the reason for that is the tessellation shader can only subdivide a surface so many times. So it's better to have a polygon every meter or so. And also tessellation gets disabled on the edge vertices so that you don't have any cracks forming on the edges. So I'm actually going to set the edge size here. I'm going to add a little skirt of geometry around the edge here. I'll set that to 2 centimeters. And now you can see how the very edges get the displacement gets disabled on the edges. And I'm actually going to set that to, let's try 8. Yeah, that looks a little bit better. If you want to create a new material for your own textures that you downloaded from somewhere, the easiest way to do that is to click on the base texture and then select the Generate Material menu item here. That's going to convert these ping files into DDS format, which is more optimized for real-time rendering. And it's going to generate a material file, and it's usually able to guess which texture is which just based on the name. And you can see it got it right here. So it has the base color texture assigned here, and then it has the normal texture assigned correctly. And now we see we have these DDS files. This is using BC7 compression format for the base texture, and then the normal map is using BC5, which is a good compression format for normal maps. Now I want to show you how texture mapping on primitives works. Now I'm using this science fiction material that has these nice big details so we can easily see how the texture is aligned. And when this texture lock setting is enabled up here in the Tools menu, if I move the object around, then the texture mapping will move to match the object's orientation. If I go up here to Tools and disable Texture Lock, then when I move the object, the texture mapping will stay in place. I can select the Face tool and then select this face here. And you can see we have these properties up here that will control how the texture is aligned. And we can use that to adjust and get it exactly where we want it on the surface. We can make it bigger or smaller with the scale values. We can even rotate the texture. Let's just set these back to the default value. And then down here we have these texture alignment buttons. And this will align the texture to an edge. There's the left edge, the right edge, the top, the bottom. This button will move the texture to the center. And then this last button will stretch the texture over the selected face. Now this last checkbox over here that says Unify Faces, I need 2 objects to demonstrate this. So I'm just going to copy this. and put another one right next to it. And then I'll select both of these faces. I'll check the Unify Faces checkbox, and then we'll stretch the texture over both faces. And this treats them as if they are one, just a single face. If I uncheck that box and I press that button, then it will adjust the texture mapping for each face individually. Vertex material painting is a really powerful technique that allows you to achieve really impressive visuals without a lot of effort. So first you want to select the material painter tool, and then I'm going to choose a material to paint onto the surface. Let's see, ground, this one. And you can see this indicator appears around the mouse, and I'm just going to click and hold the left mouse button, and you can see the material being applied. If I hold the control key, it will remove that material. And it doesn't look like there's a lot of detail in what the material I'm applying. There's not a lot of detail across the surface, and that's because by default each face will use the minimum number of vertices needed to create that face, but I can increase the subdivision of that, and this will give me more vertices to change the material of. And now I can get a much more detailed look. If I add a material that uses displacement and tessellation, let's just make sure that's turned on. Up here in video, tessellation, okay, it's set to ultra. Then you'll actually get geometric detail popping out of the surface, which looks so cool. And if you look at this let's look at this in wireframe, you can see that the tessellation is only being applied to the polygons where it's actually needed, which is a nice little optimization. And if we go back and select this face, we can see all the materials that are actually applied here. And we have some options to adjust them, or we can replace them, add some noise. So this is just a really great way to break up surfaces and give your games a AAA look. And it's really easy to use. That's pretty much it. Everything you just saw is pretty much all you need to know to use this tool. In this video, we're going to learn how to create and edit terrain. So to start, we just select the terrain tool over here, and then we can just leave it as the default resolution and press the create button. And this will create a terrain for your scene. And let's get a material on there right away so we can see it better. Let's see, ground, and let's pick soil ground. Okay, that'll be good. So the tool up here, you can select the terrain tool to use up here. We have sculpt, paint, smooth, flatten, and the vegetation tool, which we'll talk about later. The sculpt tool does what you would expect. You just click the mouse and drag it over the terrain, and it starts adding hills to the terrain. If you hold the control key, then it will actually lower the terrain. So you can raise and lower the terrain. If you hold the Alt key, then when you click, you can move the mouse up and down to raise and lower it very precisely. That's using the Alt key. Let's take a look at the paint tool. We really need another layer here, so let's see what we have. Grass, that'll work. Okay, so now when the paint tool is selected, we can just click and drag it like this, and it will just paint that material, whatever the selected material is, onto the terrain. Let's take a look at the smooth tool. This will just smooth out an area. So you can use this to smooth any jagged areas you have. And if we increase the radius a bit, You can see the effect it has a little bit better. Let's increase the strength so it works faster. And you can see how that just smoothed everything out. I need another hill here to demonstrate this. Okay. Now the flatten tool is interesting. Wherever the first point you click on, whatever the altitude is, it will just raise all the terrain to match that. So this is really good for making mesas and cliffs. Now there's a sample terrain environment here that you can download in the Downloads Manager. You need to be logged into your Leadwerks.com account. If you don't have one, then you can register one at leadwerks.com/community. It's free, and that will allow you to install all the sample scenes. So I'm going to open this this scene called Height Map. And this is just a terrain with a height map that was created in a program called L3DT and imported into the scene. And I want to show you how you can very quickly apply material layers to this to make it look good. So our first layer is we're going to use, let's see, Soil Ground 22. And all these materials are included in if you install the sample scene. That's our base layer. We don't have to do anything else there. And then we want to go to Rock and Rock Wall 01. Okay, and then before I apply it or paint it anywhere, I want to set the UV scale to 4 for this because I want it to appear bigger. And then I want to set the minimum slope to 45. And that way it will only appear on slopes between 45 and 90 degrees. And with those in place, now let's press the fill button. And now all of our steep slopes have this rock applied to them. Now let's add a grass layer. And let's see, that's going to be in ground, sparse grass. And before I apply it, I want to set the maximum slope to 15. And that means the grass will only appear on slopes between 0 and 15 degrees, so it'll appear on the flatter areas. So let's fill that in. Nice. Okay, and finally I want to add some snow. And I only want that to appear on the mountaintops. So we'll select this snow material. And I don't want the snow to appear on slopes, so let's set the maximum slope to 10 degrees. And then we're going to set the minimum height to 75 meters. And then we'll press fill. And now we have these nice snow caps. So those settings will allow you to apply materials to pretty much any terrain, and it'll look good without a lot of effort. Finally, I'm just going to add a skybox here. And there's our terrain without a lot of effort. That was pretty easy to set up. In this video, we're going to learn how to add vegetation to a terrain. So I'm going to start with this terrain that's already made from the terrain sample. And if you go to the Downloads Manager, you can click on Environments, and the sample terrain package will be here. You just press Install. You need to be logged into your Leadwerks.com account. If you don't have one yet, then you can register for free at Leadwerks.com community, and then that will allow you to download a lot of assets for free. But if you open up the finished terrain sample scene, it will look like this. And let's click the terrain tool, and then on the tool up here, let's go to vegetation. And we're just going to add a new layer. So plants and vegetation, and I'm going to start with realistic fir trees, and I'm just going to select the first two because those are both big trees. And I'll leave the third one alone because it's a very small one. And I'm going to set the maximum slope to, let's say 35. We'll try that. And then let's increase the size of the tool here a bit. And then we'll just start painting. So that's gives us an extremely dense forest, probably much too dense. Let's try setting that to 4. That looks pretty good. And you'll notice the trees are only extending to a certain distance, so let's increase that distance to 500. It's using an imposter from far away, so we can render large numbers of trees at very low cost when they're far away. So we can afford to have a pretty far view range for this. And I don't really want them appearing on the rock faces. Let's set the maximum slope to 25. Oh yeah, that's good. I just kind of want them to be on the low areas, kind of on the sides of this valley. But I don't want them up on top of the mountains. I just want to kind of frame the scene. If you hold the control key while you're painting instances on, then that will just remove them. So it acts like an eraser. That's pretty good for now. Let's add a little bit more here. Okay, so we can call that finished. Let's add another layer. I want to add some grass. So this grass dry model, this is good, and all these models will be included in the package when you download it. Let's just paint that on, and I just want this kind of down on the valley floor. I actually should have set a maximum slope. Maximum slope, let's say, let's try 25. And I'm just going to kind of erase and go back and do it again. And then I want to increase the view range to something pretty high. 300, 200, yeah, that's good. Probably 150 is fine. And let's see how dense that is. The density looks okay. You'll notice this model. It's not just one instance of grass. It's like this big cluster of grass. So that's very efficient for rendering. But unfortunately, it's making the grass levitate because the instance is positioned here, but it just sticks straight out. So I don't really like that. But fortunately, we can deal with that. If we set the alignment mode to per vertex. Oh, now the grass just conforms to the hills very nicely. I'll show you that over here again. This is the default where it's just aligned by the center, and you can see you've got this stair-stepping effect. But if we just set it to per vertex, then it just offsets all the vertices by the terrain height, and everything lines up really nicely. Let's just make sure all these flat areas are filled in. And I don't really want the grass to be growing much higher than that. Okay. And finally, let's add some rocks. Let's see. Go back to vegetation, add layer, rocks, rock moss set 2, and I'm just gonna, let's see, I'll just try the first 3. So you can select multiple files, and that will give you variations of your instances, and that gives you, that's really great because you'll have a lot less repetition that way. You can see they're all different rocks. Yeah, and that's really nice because you can just paint a bunch of them down and they'll just automatically be randomly chosen. And you can even, for each variation, the variation properties are down here, and you can even see this weight value. You can even change this to make a certain variation appear more or less frequently. So if you have a certain tree or something that's very, very distinctive looking and you don't want it showing up a whole lot, just every once in a while you can decrease its weight there, and it will be less likely to be used. So let's see, with these rocks, I think I want these along the sides of this little valley. I don't really want them everywhere. So I'm going to decrease my tool size here and just kind of use them to frame this area. I don't really want them, yeah, I just want them like at the foot of these hills, kind of. Because you're not even really going to be able to see them if they're mixed up, if they're all mixed in with the trees. So there's no need to really put them there. But they do look good along the edges. If you just do like a, yeah, just make kind of a line of them, and it looks very natural. Now these look a little bit, these still look a little bit odd. So for each of these variations, I'm going to set the alignment mode to rotate to normal. And what this does is exactly what it sounds like. It just rotates the rock to kind of match the slope that it's sitting on. And that just looks a little bit, yeah, especially, you can see it really well right there. It just looks a little bit more natural. So that's a good thing to do with rocks like this. So without a lot of effort, without a lot of time, without a lot of artistic skill, I was able to just populate this whole area in a way that looks pretty natural. All using free assets that are available in the download system. So that's pretty much all you need to know to use the vegetation system. I look forward to seeing what you're able to create with it. Have fun! In this video, I want to show you how the entity component system works. Now, components are a script or a piece of code that gets attached to an entity, and it adds some behavior to that entity. Each entity can have one, or it can also have multiple components. So this this pivot right here, it has the FPS player component, and this just turns it into a playable player controller. And then over here, let's see, this has a sliding door component attached to it, and this object here has a swinging door component attached to it. And you can probably guess what those do, but let's just run the game and see. So the FPS player component, that gives me my controls so I can move around the scene. And then if I walk up to this door and I press E, it slides open. I can close it again if I want, or open it again. And this is the swinging door component, so if I walk up to it and I press the E key, then it does what we would expect it to. So that's a really simple example how we can use components to just add behavior to different objects. And what I want to do now is I want to create a custom component with you right now. Let's go to, let's see, new. Okay, we have to be in the project tab and then new component. And the group I'm going to put this in doesn't really matter right now. I'll just put it in motion. And I'll call it custom component. Okay. And this is a Lua project, so it's going to generate a Lua file. And it's also going to generate this JSON file, that's just used by the editor to store all the values that are provided here. And this just sets up a bunch of predefined values that appear in the editor. And this just shows you all the different kinds of things that you can create. So let's see. Okay, I'm selecting that green box in the middle, and then I want to go to, I'm pressing the Add Component button, and then go to Motion, Custom Component. That's my component I just created, so I'll double click that. And you can see here how all these different values are exposed in the editor, and these all correspond to, these are all harvested from the code here. And then where they actually get stored, they actually get stored in this JSON file, which it's not important for you to know. You don't really have to deal with this file because this is just auto-generated, but it is kind of interesting to see how that gets laid out. So I don't really want all these values. I'm just going to leave, let's see. I think I want a vec. I'm going to use a vec3 value later, so I'm just going to delete everything except that. And then I'll save the script. And you can see the properties that are exposed to the editor just got changed. And now we're going to write a little bit of code, but don't worry, I'll make it easy. Basically what I want this component to do is when I press a key, when I hold a key down, I want this box to turn. So let's see, first we need to get the window. So I'm going to say local window equals active window. And that retrieves the currently active window. I could also use the, let's see, if we look in main.lua. Okay, well this is a local variable anyways, but I could make this like, I could say like main window equals that value, and I could store that as a global variable and then access it in here. But if I just use the active window, that makes it so that this code is more likely to work without requiring any special code and anything else. So you always want to try to make your components as portable as possible. And then active window can return null. It can return nil, which is null in Lua. So if window equals nil, then we'll just stop. And we'll just exit out of the function if that happens. And a reason it might return nil is because if the game window is not currently selected, if some other window has the focus, then active window won't return a valid window. So that actually can happen. Okay, so if window key down, key T, then so that's saying if the T key is pressed down currently, then self.entity, which is the object itself, turn 0, 1, 0. So it'll turn it 1 degree on the y-axis. Let's make it 5 degrees. That might be a little bit slow. Okay. And let's just run the game and see what happens. Okay, so I'm going to walk up to this and I'm going to press the T key. And it works. Cool. Okay. Well, now I want to make this a little bit more advanced. I'm going to call this, let's see, I'm going to change the label here to rotation speed. And then I'll change the name of the variable here to rotation speed. That's just a little bit nicer. So this is the label that appears in the editor, and this is the actual name of the variable. And so what I'm just going to do here is I'm going to go, instead of using a hard-coded rotation value, I'm going to go self.rotation speed, and then that way I can adjust the value I want in the editor, and that way I can reuse this component in different places and change that rotation speed without having to adjust any code. So it's always a good idea to have some customizable values in your components, and that way the person using it can just modify the values in the editor and reuse the same code over and over again, and they can get more usage out of your components without having to actually dig into the code. So we'll save that, and that should give us rotation speed. Yeah, okay. And I'll set it to 2 on the y-axis this time. And if we run the game, that should be enough to work. So let's press the T key. And you can see it's moving more slowly now, so that value actually is coming through. So that's a basic oversight of how the entity component system actually works. It's very powerful. Again, you can have more than one component per entity, but you can only have one component of the same type for each entity. And that just avoids a lot of confusion. So yeah, this is the basis of all your game programming in Leadwerks. Now the entity component system, it mostly functions on a per object basis. And we have another system that handles communication between objects. A lot of times when you're designing gameplay, you'll have a complex sequence of events that involves a lot of different objects interacting with each other. And it's nice to have some kind of visual way of setting all of those interactions up. And that's where the flow graph system comes in. So in this scene, we have 2 doors that are set up to just open and close manually. And then we have 2 other doors, and these are linked to these trigger fields, which will appear invisible when the game is played. And all of that is done in this interface here. If you click on this button, it will open up the flow graph editor interface. And you can see that the object that is selected in this view corresponds to whatever is selected in the scene. If you want to add another object to the flow graph interface, you just drag it here and it will appear. And then you can right click and hit remove to get rid of it. And you can see these 2 trigger fields. These are connected to the corresponding door. So the collide output here is connected to the door open function on this swinging door, and then for the other trigger, collide is also connected to the open function on this sliding door. So let's see what happens when we run the game. So we have these two manual doors, and they open when we press the E key, like before. And then we'll walk up to this invisible trigger field, and that automatically activates the door. And it keeps it open as long as I'm in that field until I step out, and then it will close after a moment. And the other one works the same too. Now the reason those are closing automatically is because we have this close delay value set to 1. That means that it will automatically close 1 second after it stops being opened by you standing in this area here. And then on these doors, that close delay is set to 0, which just disables the auto close behavior. Let's try swapping these values. We'll make one door, one trigger field go to the other door, and we'll just switch them that way. And let's see what effect that has. So now when I step in this trigger field, it opens the other door. And yep, it works on that one too. And the way this is controlled, it's really simple. Let's look at the sliding door script. If you want to make a function an input, then you just write a little comment afterwards, after the function declaration that says in. If you want it to be an output, then you just have to type out. If you want it to be both an input and an output, then you just write in out. And that will just expose it, then the editor will pick up on that, and it will show it in the flow graph editor as something that you can, it'll show it right here so that you can use it. Okay, I'm feeling creative, so let's take our custom component and let's try something. Let's see, custom component, okay. And I'm gonna write a new function here. I'm gonna call it function custom component turn. And then I'll just copy and paste this code that makes it rotate according to the rotation speed that is set in its properties. And importantly, I'm going to write dash dash in, which marks it as an input function. I'll save that. And then go to the flow graph editor. And we already had it selected, so I know that this box is the right one, even though it's just called box. We'll drag it into the view here. There's our input. There it is. Now I'm just going to drag from collide to here on both of them. And so when I step in the trigger field, either of these, then they should activate this turn function, and we should see the object turn around automatically. Let's see if it works. There it is. We're still opening the other door because we have those inputs flipped. But in addition to that, we're also making the box spin, and it stops spinning once we step out of that field. So components are a lot of fun to program. You can do a lot with them, and it's a lot of fun to think of all the different ways they can be used, all the properties that you can expose so that the level designer can have a lot of freedom to do different things with them, and all the inputs and outputs that you can allow that will let level designers do very creative things with this. And you know, if you have a good system of components, then the level designer can just create pretty much anything they can imagine, and they don't even have to use any programming. So you can set up very, very complex behaviors with this system, and it's a lot of fun. And that's kind of how the whole development process in Leadwerks, this kind of ties it all together. Ultimately, at the end of the day, it's the level designer is setting up interesting interactions with components, and it's just a lot of fun, and I can't wait to see what you're able to do with it.